a bustling forensic laboratory, Detective Smith, a seasoned CSI, is about to teach Officer Johnson, a rookie CSI, the crucial differences between physical and trace evidence, emphasizing the significance of various scientific techniques and vocabulary in forensic science.
Before we begin, let's familiarize ourselves with some important vocabulary, including terms that are vital for understanding both traditional forensic science and the digital realm.
Acid, a compound capable of donating a hydrogen ion to another compound.
Acid phosphatase, an enzyme found in high concentration in semen.
Catalyst, a substance that accelerates the rate of a chemical reaction, but is not itself permanently changed by the reaction.
Electrophoresis, a technique for separating molecules through their migration on a support medium under the influence of an electrical potential.
Enzyme, a protein that acts as a catalyst for certain specific reactions.
Chemical composition, the individual chemicals that make up a substance.
Gas chromatography, a common type of chromatography used in analytical chemistry for separating and analyzing compounds.
Paper chromatography, dye or ink is applied to filter or chromatography paper placed in a solvent and pigments are separated.
Mass spectroscopy, an analytical technique that measures the mass-to-charge ratio of charged particles.
Morphology, a branch of bioscience dealing with the study of the form and structure of organisms and their specific structural features.
Natural fibers, fibers derived from plants or animals.
Physical evidence, any materials that would be present at the crime scene on the victim or found in a suspect's possession.
Pigments, a material that changes the color of reflected or transmitted light as the result of wavelength selective observation.
Synthetic fibers, fiber created from natural materials or by chemical processes, a man-made fiber.
Trace evidence, physical evidence that is found in small but measurable amounts, such as strands of hair, fibers, or skin cells.
Good morning, Officer Johnson. Today we're diving into the intricate world of physical and trace evidence. Are you ready to connect the knowledge to contemporary crime-solving challenges?
Yes, Detective Smith. I'm eager to learn, especially how this applies to situations like cyber forensics and document analysis.
Physical evidence refers to tangible objects or substances directly related to a crime. It can include anything from a murder weapon or fibers found at a crime scene.
Trace evidence, on the other hand, consists of small, often microscopic materials that can link a suspect to a crime scene. These include hair, pigments, and even chemicals like acid phosphatase, which indicates the presence of bodily fluids.
Take a look at these items, Officer Johnson. Can you identify which ones are physical evidence and which represent trace evidence?
It's definitely physical evidence, while these minute fibers on the victim's clothes must be trace evidence.
Excellent, Officer Johnson. Physical evidence is tangible and often straightforward to identify. Now let's delve deeper into the analysis of trace evidence.
To analyze trace evidence, we utilize various scientific techniques. One key method is gas chromatography, which separates components based on their chemical composition.
This technique is also applicable in cyber forensics to analyze substances related to digital crimes, such as identifying chemicals and hacking tools employed by malicious hackers.
Observe this machine, Officer Johnson. It separates compounds from their chemical composition, similar to how we analyze online behaviors during penetration testing and chemical acting.
Got it, Detective. Gas chromatography separates compounds based on their chemical composition, enhancing our understanding of the evidence.
Another valuable technique is paper chromatography.
Paper chromatography is employed to separate pigments from substances like ink or dye. This method is crucial in document analysis for detecting forgeries.
Here we have paper chromatography. It separates pigments into substances like ink. The pigments disperse, revealing their distinct colors, which can authenticate documents and detect alterations.
Paper chromatography separates pigments in substance like ink, revealing their unique unique characters essential for forensics document examination.
Lastly, we have mass spectroscopy.
Mass spectroscopy measures the mass-to-charge ratio of charged particles, which can identify specific substances akin to pinpointing chemicals used in cybercrimes.
Explaining. Mass spectroscopy measures the mass to change ratio of particles, assisting us identifying substances, whether in a crime lab or analyzing digital evidence for cyber operation.
Mass spectroscopy identifies substance by measuring mass to charge ratios, vital for both physical and digital forensics.
So, Officer Johnson, physical evidence is tangible, like this knife, while trace evidence such as fibers and chemicals may be small but is crucial. We employ techniques like gas chromatography, paper chromatography, and mass spectroscopy to analyze trace evidence and ensure document authenticity.
You've grasped it, Officer Johnson. Remember, in forensic science, understanding the distinctions between physical and trace evidence can make it or break the case, whether it's uncovering fraud in documents or identifying digital threats.
Thank you, Detective Smith. I'm ready to apply what I've learned partially in preventing crimes like forgery and understanding financial forensics.
Thus, in the realm of CSI, knowledge is power. With each case, Officer Johnson is one step closer to becoming an expert in distinguishing physical and trace evidence and applying this knowledge to real-world challenges in both traditional and cyber forensics.
See,